Alright, and welcome to Applications of Vertex Form. Now, in this very first problem, it says a cannonball is fired across the battlefield. The trajectory of the cannonball is modeled by the function below. How high did the cannonball fly? Okay, so this is kind of interesting. So we could say, we have some sort of, let's see here, like some sort of cannonball, and it's going to shoot out of this cannon, and then it's going to go in what we call a parabolic trajectory, or aka a hyperbola, which is really the graph of a quadratic. And then it's going to land here somewhere, but this graph is actually asking this question: what is the highest point that the cannonball reached? Okay, so let's kind of go ahead and tackle this. What we want to do is, in order to find the highest point, which of course we call the maximum, well, we're going to have to find the vertex. And the best way to find the vertex is simply to use vertex form. So we have this function f of x equals negative 1.2x squared plus 6x plus 7.8. And it's in standard form of ax squared plus bx plus c. And let's see, what we're going to do is go ahead and complete the square and turn it into vertex form. So we know the first thing we want to do is put into parentheses negative 1.2x squared plus 6x. And this 7.8 is not our perfect constant, so we just kind of shove it to the side. Rude. Okay, now from here, in order to create our perfect, the next thing we want to do is we recognize that our a value is not equal to 1, kind of like our previous video. So we want to factor out this negative 1.2 from both of these terms inside the parentheses. So now I have f of x is equal to, and I factor it out to the very front, negative 1.2 parentheses. Negative 1.2 divided by negative 1.2 is 1x squared. And then a positive divided by a negative is going to be a negative. And 6 divided by 1.2, let's just double check that in our calculator, is actually going to give us negative 5, negative 5x. Okay? And we'll put a parenthesis here, and then we'll put our plus 7.8. Now, you'll notice that in these real-world problems, we're typically going to have to deal with decimals. We're not always going to have nice, neat whole numbers, and that is a-okay. So in this particular example, what we want to do now is we want to find our perfect square. Remember, our perfect constant. And you find your perfect constant by using our little trick, which is called completing the square. Okay, so how in the world do we complete the square? Remember, you have to memorize this, b over 2 squared. In this case, we have negative 5 is our b term. So all right, negative 5 over 2 squared. And negative 5 over 2, I think it would be best if you wrote this as a decimal. So we'll write negative 2.5 squared. Well, if you were to do negative 2.5 times negative 2.5 in your calculator, what you're going to get is a positive 6.25, okay? So we're going to add this plus 6.25 as our perfect constant. Now notice though, you just added a number to the right side of this equal sign. You just add a number to this right side of the equal sign. So we have to balance this out somehow. All right, so what I would encourage you to do, and I'll always encourage y'all to do this as you're first learning this, is say, okay, this 6.25 is not really a 6.25. It's really 6.25 times negative 1.2. So what is 6.25 times negative 1.2? And that's actually going to give us negative 7.5. So what you really added to the right side of this equation was a negative 7.5. In order to balance that, you're going to need a positive 7.5. Okay? So one more time. You put this perfect constant, 6.25, and you got that. You then multiplied it by the thing we factored out earlier, negative 1.2, and this gave you a negative 7.5, which we balance out with that positive 7.5. Now from here, we just do everything like we've been doing, even if it's going to look a little bit different to you. We write f of x is equal to negative 1.2 parentheses. Remember, when you complete the square here, you're going to write parentheses x, you leave a space, and you square it. And then here we have 7.8 plus 7.5. My guess is 15.3, but let's use our calculator. 7.8 plus 7.5, which is 15.3. Oh, 0.3. And then from there, remember our trick. You're looking for, and this is going to sound so weird, two numbers that multiply to be 6.25 and add up to be -5. And that can be incredibly difficult. So what's our trick? We always take our b term and we always divide it by 2. So it's -5 divided by 2. Well, that's going to give us minus 2.5. All right. And there you go. There's our vertex form. Now, this still doesn't answer the question, because the question is, how high did this cannonball go? And so let's grab our eraser here. Let's put a little space for ourselves. Okay, so we have this little space. And we're going to say, you know what, our vertex, we always take what's inside the function, so that x minus 2.5. We set it equals 0. And what's the opposite of minus 2.5? Well, that's plus 2.5 and plus 2.5. And this gives us x equals positive 2.5. And from here, we'll say, okay, our vertex is at 2.5, comma, and this k value is 15.3. And you want to ask yourself, okay, well, if that's where my vertex is at, it's at 2.5, comma, 15.3. Which one of those numbers tells you how high the cannonball went? And that number is always going to be your y value, because your y value is the height. So we can say this cannonball shot up a height of 15.3 feet. All right? Perfect. Okay, I hope that this helps, and I know that this can be a little bit difficult. So I'm going to go do example or problem number 2. What I would encourage you to do is pause the video, try out problem number 2 on your own, and then when you get stuck, come watch how I work it out. All right, thank you. Okay, here's example 2. It says a baseball is thrown and the path of the ball can be modeled by the function f of x equals -3.4x squared plus 10.2x minus 1. How high did the baseball go? So you can kind of think of it like this. We've got our little person, our little stick figure, and they're going to throw a baseball. And what we're saying is, okay, you know what? How high did that baseball go? So basically, once again, what we're asking for is where is the maximum or of, our vertex, and, basically like, okay, well, how high did that ball go? Okay, in order to do this, to find the vertex, of course, we want to turn this into vertex form. So let's go ahead and write it as such. F of x equals, we put our parentheses, -3.4x squared plus 10.2x. And remember, what we do is we leave space for a perfect constant by pushing this imperfect constant off to the right. Okay, so wait a second. I noticed that my a value is not equal to 1. So I want to divide everything here by -3.4 and by -3.4. Everything inside the parentheses, that is. So now I write f of x equals -3.4 parentheses, and I know that -3.4 divided by -3.4 is just 1x squared. Now I should probably use a calculator, and 10.2 divided by -3.4 is actually going to be -3x, I leave my space, minus 1. Now from here, what we want to do is we want to create our perfect constant. And once again, we do this by completing the square. Okay? Well, how in the world do we complete our square? I've asked you to memorize this, and I think we've worked out about 3 or 4 examples now together. So pause the video and see if you can write down the formula for completing the square. And, of course, it's going to be b over 2 squared. In this case, you always use the b term after you factor out that -3.4, or after you factor out your a term. And so in this case, our b term is -3 over 2 squared. Now you might need to use a calculator for this, because this is going to give us a decimal, but it'll give us -1.5 squared, which is really saying -1.5 times -1.5, which will give us positive 2.25. So let's write that in, plus 2.25. Now from here, remember what you've just done is you've added that to the right side of this equation, but we have to keep it balanced. And so what we want to do is take that positive 2.25 and multiply it by the negative 3.4. So let's go ahead and grab our calculator. Negative 3.4 times 2.25, and that's going to give us negative 7.65. Now from here, let me kind of erase this stuff and get it out of the way. In order to balance that out, what we were going to say is, you know what? To balance out a negative 7.65, we need a positive 7.65. Okay, and from there, we can begin our final stages of turning this into vertex form. Okay, so I go ahead and I write it as f of x equals, I write my a value, negative 3.4 parentheses. Remember our little template, parentheses x space squared, because we're talking about a quadratic function here. And our trick for filling the inside of this parentheses in is always to take our b term and simply divide by 2. So negative 3 divided by 2 is negative 1.5. And on the outside, negative 1 plus 7.65 is going to be positive 6.65. And so here's the vertex form that models the basketball. And if I take what is inside the parentheses, x minus 1.5, and I set this equal to 0, well, I can add 1.5 to both sides, and I get my x value is equal to positive 1.5. So this vertex up here is really at the point 1.5 comma 6.65. And so if I were to tell you that, hey, like he's shooting for the rim, he's shooting for the hoop, he's trying to make a basket. Oh wait, this is a baseball. Okay, if I were to say, hey, is he throwing the baseball really high? You would say, not really. 6.65 feet is not that high up in the air, because that is in fact how high he's throwing it. Alright, y'all. Well, thanks for coming to this video, and I'll catch y'all in our next video series.